We can describe gases using four factors. We can describe them using the number of particles, which we use as moles. We can use temperature, which we're going to do in Kelvin. We can describe them using their pressure and also using their volume. So temperature we know is a measure of the average kinetic energy, which the kinetic energy is energy of motion. So temperature is directly related to how fast the particles are moving. So when we look at temperature, we use what's called the Kelvin scale. This is based on absolute zero. Absolute zero is the point at which all motion stops. Okay, nothing moves at zero. This is 0 Kelvin is negative 273 degrees Celsius. It's about negative 450 degrees Fahrenheit. So our formula, and this is in your formula page on your reference packet, Kelvin is equal to your degrees Celsius plus 273. It's a fairly simple conversion. So if we rearrange that to change Celsius, or change from Kelvin to Celsius, you subtract 273. So if you have a question, 40 degrees Celsius is what temperature on the Kelvin scale, we would put it into this equation here. So 40 plus 273 would give me 313 Kelvin. Or if we wanted to convert 252 Kelvin to degrees Celsius, we would put it in the second formula. So we would say 252 minus 273, and we would get negative 21 degrees Celsius. Now when you're doing gas laws, you have to use the Kelvin temperature always, because we base our gas laws on kinetic molecular theory, which is based, which uses the Kelvin scale. It's based on absolute zero. So pressure is a measure of the force per unit area. And when we're talking about gases, what we do is we measure the force of collisions that the gas particles have on the canister that they're in. Okay, so our learning targets, we're going to make pressure conversions. So remember that force is the strength of the collisions. Okay, now units are different for pressure. Kilopascals, we use kPa, little k for kilo, and pascals is pa. Atmospheres is probably the most common. We use ATM to abbreviate that. Torr is the same as millimeters of mercury. If you ever watch the news and they talk about centimeters or the height of mercury, they're talking about the actual height of mercury in a barometer. And then that's also called torr. Now we use what's called a manometer to measure pressure. A special type to measure air pressure is a barometer. So some conversion factors that you're going to see, we're going to take a more in-depth look at those. If we look at our reference packet, now this is the very, very first page, and we look right here at the standard pressure line, you're going to find all of your pressure conversions, and we can pull this out and we can say that they're all equal to one another, just like I've done down here. So 1 atmosphere is equal to 101.3 kilopascals. 1 atmosphere is also equal to 760 millimeters of mercury. 101.3 kilopascals is equal to 760 millimeters of mercury. 760 torr is equal to 760 millimeters of mercury, because torr and millimeters of mercury are the same thing. So you can set any of those equal to one another to come up with a conversion factor. So let's look at an example problem and see how that would work. So our example problem says a gas sample has a pressure of 800.0 torr. Again, you know, I'm reading my problem, I'm underlining, and I'm going to circle. What is the pressure of this gas? Now we do need to know in ATMs and in kilopascals. So we actually have two problems that we're going to do here. So we need to know what the conversion factor is between torr and atmospheres first of all. So I'm going to look right here in my reference packet, and I see that 760 torr is equal to 1 ATM. So if 1 ATM equals 760 torr, then I can make that a fraction and set up a proportion. So this becomes a conversion just like we've done. So if 1 ATM is 760 torr, then x over 800 torr is going to get me atmospheres. So when I cross multiply this, let's see, I'm going to get 760 times x equals 800. So I divide by 760 and I get an answer, where is it, of 1.05 ATM. Now if we're going to do 800 torr to kilopascals, now at this point we have our atmospheres, so we could use atmospheres and kilopascals, or we could go back and use torr and kilopascals. Either way will work. And because I like ATMs, I'm going to go ahead and use that. So if I look up here, I see 1 ATM equals 101.3 kilopascals. Then I can do 1 ATM over 101.3 kPa equals 1.05 ATM over x. And then I can cross multiply here, okay, and I'm going to get 106 kilopascals. Now it will work exactly the same way if we do our torr and kilopascal, okay. If we see that 760 torr equals 101.3 kilopascals, see that's here, okay, we can set that up as a fraction and cross multiply and we will still get 106.6 kilopascals. So there's your pressure conversion. We will do some practice problems in class. Now let's go back and finish talking about our other factors. Now volume you're familiar with. You've done these volume formulas in all kinds of math classes. But let's focus on our volume of gases. Okay, it's the amount of space that's taken up by a substance. And we're going to measure it in liters. The gas is going to expand to fill its container. So whatever the volume of the container is the volume of the gas. And like I said, we do measure that in liters. Now we have to look at some conversion factors here. Sometimes you may see cubic decimeters. 1 cubic decimeter is equal to 1 liter. And you may see cubic centimeters, and that's equal to 1 milliliter. We're also going to learn how to convert between moles and liters at STP. So 1 mole of a gas is 22.4 liters at STP. So what does STP stand for? Because you're going to see those 3 little letters stuck together. STP is standard temperature and pressure. Copy this in your notebook, folks. Get it in there so that you won't forget. Standard temperature and pressure. Standard temperature is going to be 0 Celsius, but remember we always use Kelvin, so that's 273 Kelvin. Standard pressure values are those pressure conversion units that we were using. 101.3 kilopascals, 1 ATM, and 760 torr. Now all of this is on that first page of your reference packet. Okay, so I'm going to go back to that screen right here. Okay, standard pressure, standard temperature, volume of 1 mole at STP. So it is all right here in your reference packet. Okay, so what I want you to do is I want you to take a marker, highlighter, some sort of writing utensil, okay, and I want you to take and really big, now let me get a funky marker, okay, really big right here, I want you to write S, oh that's not going to work, S, look at my computer, T, P. Okay, so STP is going to be right here. Now don't, make sure you can read your stuff here. But really, where you can see it, I want you to write STP on standard pressure and temperature so that you will see it on your reference packet. Okay? Alright, I think that is going to wrap it up for this video. Let's just make sure. My computer's not cooperating. Yep, that's it.